Okay, well, we've been talking about how pre-Columbian cultures used metals, and then we started talking, had a nice discussion about what happened during the Spanish colonial period, especially in Mexico and Peru. And today we're going to talk about what happened after some of the nations got independence. And in particular, we're going to talk about mining of copper in Chile. So Chile is the longest and narrowest nation in the world. It's not that much bigger than Texas, but whereas Texas is kind of equant, you know, Chile is long and drawn out like a string of spaghetti. So it's got about 17.5 million people, about half what we have. And it is one of the wealthiest nations in Latin America. And we'll talk about some of the reasons why, with a per capita GDP of over $12,000. So let's just compare Chile, Texas, and Mexico. So Chile, we've said, is like 750,000 square kilometers. Texas is a little bit less than that. And Mexico is much bigger, almost 2 million square kilometers. Now, one of the things that people get confused about are the Texas and Chile flags because they look kind of superficially similar. So here on the left, we can see Texas, and here on the right, we see Chile. So just keep that in mind that they look an awful lot like, but they're not the same. So we're going to start talking about the Atacama Desert, this region in northern Chile. And so the Atacama Desert extends for 1,600 kilometers or 1,000 miles. It's very sparsely populated. It's almost no rain. Runs from the Pacific Ocean over to the Andes not far away. And the desert itself is usually less than 100 miles across. First European to cross the Atacama Desert was a Spanish conquistador in 1537, of course looking for riches, but he didn't find any. But from then until about the middle of the 1800s, it was largely ignored. So it is the Earth's second driest region after Antarctica. Antarctica, people sometimes surprised that it's so dry, but it's cold, so the dry stays locked up in ice. But the Atacama is the second driest region. And it's made up of salt basins or salars, which are going to figure prominently in this course later, and then sand and rock outcroppings, like you can see down here and down here. Next slide. So it's so dry that NASA used it as an analog for Mars for testing some of the rovers and other things. So we're going to watch a 1-minute video about that, and it'll give you a feel for it. You know, just watching this fellow try and talk while the wind is blowing in his microphone. So it gives you a feel.
Guys, so I'm here in the baked hills of Chile around San Pedro de Atacama, and believe it or not, this is where NASA did testing on the the rover before they sent it up to Mars. And you can see why whatever images we might have seen from Mars look very similar. You can see these hills, these very arid hills. There's not even really a trail here. We're pretty much off the map at this point, and we biked up here. But you can just see, you know, it's very desolate, and it's probably one of the most quiet places on Earth right here. This is actually the best place to see stars in the night sky because the air is so clean and there's no lights whatsoever. So, wow. Here from San Pedro de Atacama area in Chile, Rich for RichTrack.com, signing off.
Hope you enjoyed that video. The first thing that the Atacama Desert became a target of interest by other nations was because of nitrates and agriculture. So nitrates are critical for plant growth. The atmosphere is almost 80% nitrogen, but most plants can't use nitrogen in that form. It's too hard to break those bonds between the two nitrogen atoms. They need it in the form of nitrate, NO3, you know, minus, you know, with some cation in front. But until the 20th century, nitrate had to be mined, and there were very few places where you could mine it. So another reason we know about nitrates is that they are used in explosives. So trinitrotoluene is more commonly known as TNT. Specifically, it's this chemical word that I'm not even going to try to pronounce. But you can see it's a lot of carbon, a lot of hydrogen, and nitrate here in the middle. So you need nitrate to make that. Now another term that people are familiar with in terms of explosive is nitroglycerin. So nitroglycerin is dense, colorless, oily, and very explosive liquid. It's a nitrate compound, and it was invented in 1847. It's been used ever since as an active ingredient in the manufacture of dynamite. So basically, nitrates in any form are very reactive, and in fact, terrorist Timothy McVeigh killed 168 people in Oklahoma with 2.5 tons of nitrate fertilizer in 1995. All right, let's get back to the Atacama Desert, the mineral resources. So it has the world's largest supply of sodium nitrate. So that's the formula there for sodium nitrate. And this was mined on a large scale until the early 1940s. And rich deposits of copper and other minerals became more important after that. The port city of Antofagasta here in the north is a major port, was a major port for exporting sodium nitrate, and now is a major port for exporting copper and other minerals. So here we've got a view of Antofagasta on the Pacific. It's way north of Santiago, the capital of Chile. Has a population of about 400,000. So after the wars of independence in Latin America, which went on in the early 1800s, Bolivia claimed Antofagasta as part of its territory, and Chile originally recognized Bolivian jurisdiction in 1866, but then changed its mind in 1879. And Antofagasta was captured by Chile in 1879, triggering the War of the Pacific, which it was 1879 to 1883 between Peru and Bolivia on one side and Chile on the other. So Chilean sovereignty was officially recognized by Bolivia in 1904. So let's talk a little bit about the War of the Pacific, 1879 to 1883. This is what the map looked like before the war. So you see Chile stops here at this latitude, and Antofagasta was part of Bolivia. Bolivia had a port and a coastline, and then Peru extended well down here. So there was a treaty in 1866, and Chile and Bolivia divided this region, at 24 degrees, and with the understanding that both nations could freely exploit the mineral deposits in the region and would share equally in all the revenue generated by mining activities. But Bolivia soon repudiated the treaty, and its subsequent levying of taxes on a Chilean company led to an arms race between Chile and its northern neighbors of Bolivia and Peru. So, in February of 1879, Chile ordered its military forces into Antofagasta, which is right here. 2 months later, Peru, an ally of Bolivia, declared war on Chile, and then the war was on. Chile won, and it included won considerable territory, including everything from Antofagasta and the provinces of Tarapacá and Arica from Peru. All right, so here's a view of Antofagasta from the old nitrate pier looking back towards the city. And as we said, the Atacama Desert was the center for mining of sodium nitrate used in fertilizers and explosives. The mining of sodium nitrate was a bonanza for Chile that lasted for 4 decades until synthetic nitrates were produced by German chemists in the early 20th century. And export taxes on the nitrates that were shipped out of Antofagasta furnished over 50% of all of Chilean national state revenues. And the income of the Chilean treasury nearly quadrupled in the decade after the War of the Pacific. And the mining bonanza generated demand for agricultural goods from central and southern Chile and for manufactured items, and spawned a new wealthy class in Chile. So, just to tell you what happened to nitrates, this was Germany came up with the Haber-Bosch process. So saltpeter is the active ingredient in gunpowder, and it's a group of chemically similar compounds that are nitrates. Could be potassium nitrate or sodium nitrate. And until the 20th century, these nitrate compounds had to be mined. And they could only be found in natural deposits like in the Atacama. But just before World War I, German chemists discovered a way to synthesize nitrates artificially. It's easy to find nitrogen since it's 80% of Earth's atmosphere, but atmospheric nitrogen is so stable when bonded to itself as N2 that it wouldn't react with other chemicals under ordinary conditions. And that's how it stayed until the German scientists applied themselves. By the beginning of the 20th century, Germany was the undisputed world leader in new chemical and pharmaceutical manufacturing, and also led Europe in electricity production. And these factors converged in 1909 when German chemist Fritz Haber figured out how to fix the atmospheric nitrogen using large amounts of energy under very high pressure. So by raising the pressure to about 200 atmospheres, boosting the temperature to 450 degrees centigrade, and using iron as a catalyst, he could split a molecule of atmospheric nitrogen and recombine it with 3 molecules of hydrogen to form 2 molecules of ammonia, which is just NH3. And then ammonia is easy to convert to nitric acid, which is, can be turned to produce nitrate compounds. And this fellow, Karl Bosch, another German, figured out how to take Haber's process and scale it up to industrial quality so that they could make big volumes of it. So in September of 1913, there was a plant in Germany began producing ammonia at the rate of several tons a day, increased to 20 tons per day the following year. During the war, the German government scaled up the capacity to 500,000 tons of ammonia per year. They needed this for the munitions that they were using in the war. And nitrates unfortunately lengthened the Great War because it enabled Germany to fight on. Germany was cut off from natural supplies of nitrates, but they could make their own nitrates through this process. In spite of that, the benefits of the Fritz Haber process for humanity are tremendous. It's estimated that each of us, about half the protein in our bodies is made up of nitrogen that was made using the Haber-Bosch process, while 1/3 of the planet's population depends on most of its nutrition on food growing artificial fertilizers produced with the process. You may have heard about the Green Revolution, and this is the key element of the Green Revolution. So Haber and Bosch both eventually received Nobel Prizes for their work. All right, so as you can imagine, there was a boom in nitrate mining, and then with the German discovery of how to make it from air, that boom was over. It's a boom and bust. You can see it here. So this is the percentage of government revenue in Chile from nitrate exports, from basically nothing in 1880 to almost 70% in 1895, and then back down to 25% or so by 1930. And here we see the nitrate deposits here in this. This is the city of Iquique, and it's there in the Tarapacá province, which Chile took from Peru. And this shows the nitrate production in that region, and then that decline. So basically, Chile benefited tremendously, and then all of a sudden, it's gone. That gift did not keep on giving. So here we can take a look. This is a space shuttle photograph of the Atacama Desert. Here's the Atacama Desert, all of this, Pacific Ocean, looking down, Antofagasta is here, and all of this is coastline. So the Atacama Desert is a high and cold desert. Its average temperature ranges from about 32 to 75 degrees Fahrenheit. It's completely barren, and while most of the area receives moisture from the fog or a shower every few decades, the rain gauge at Calama up here has never recorded any measurable precipitation. Next. So let's watch a 4-minute video, a little bit about the Atacama Desert.
The Atacama Desert, located in northern Chile, is the driest place on Earth. It is so dry that some of the weather stations in the Atacama Desert have never received any rain. There are picturesque landscapes and magnificent sunsets. However, at some points there are lagoons and streams, and settlements around an oasis. Our first tour took us to the salt flats of Atacama, the second largest in the world after the one in Bolivia. This is the Chaxa Lagoon within the salt flats, where you can see Chilean flamingos. The Chilean flamingos have pink feathers and large bills, the front half of which are black. Flamingos are filter feeders, feeding on algae, invertebrates, and diatoms. This flamingo has unusually hyperactive legs. We also spotted a flock of ducks. The next tour took us to the Moon Valley, its landscape living up to its name. The surface is covered with salt deposits. Here you can see ruins of old Chilean salt mines and worker huts. Due to its unusual appearance, the area has been used as a location for filming Mars scenes such as the voyage to the planets. This is a high-angle view of Moon Valley from Kari Lookout. The landscape looks quite extraordinary. We are seen here walking to the lookout of Death Valley. You can see gigantic dunes and rocks and spectacular volcanoes of the Andes in the background. Due to the dryness and lack of humidity, this place is sterile. Nothing will grow, nothing will decompose, including human bodies. This well-preserved Inca mummy is exhibited in the Archaeological Museum in San Pedro. We are seen here climbing the Great Dune in Moon Valley to witness a sunset. The climb is by no means easy as we are at a high altitude. Pat is seen here feeling on top of the world as she waited for the sunset. Another view of Moon Valley in the warm glow of the setting sun. A desert sunset. Spectacular warm colors. This video is only the highlights of what you can see and do in the Atacama Desert.
I hope you enjoyed that. These remarkable conditions in the Atacama has attracted astronomy because you've got no clouds and you're up pretty high elevation and the skies are clear, and astronomers love that. And it has the clearest skies in the world. There's only 20 days out of the year is there a cloud in the sky. And the observatories began in the late 1960s, and since that time a large number of astronomical observatories have been established there, and more all the time. So if you're interested in astronomy, you're going to learn something about Chile and the Atacama Desert sooner or later. So here is the European Extremely Large Telescope, or EELT. When it's completed, it'll be the world's largest optical or near-infrared telescope. It consists of it's a reflecting telescope with a 130-foot primary mirror and a 14-foot secondary mirror. And it's under construction now, and they think it'll finish it in 2025. Okay, so now we're looking from space again but now we're looking south above the Atacama. There's the Salar de Atacama. We talked about salars as dry lake beds. Then there's volcanoes in here, just off to the east. Argentina over here, the Pacific Ocean over here, and the fog coming in from the ocean over here. All right, let's switch elements from nitrogen to copper. So copper is element 29, comes from the Latin cuprum, which is named after the island of Cyprus in the Mediterranean because Cyprus was a great source of copper. It's man's oldest metal. It dates back more than 10,000 years. There was a copper pendant was discovered in northern Iraq that goes back to about 8700 BC. Copper is an extremely ductile metal. It's easy to work. It has a pleasing color and luster. It takes a high polish, and it forms alloys readily with almost all metals. It conducts heat and electricity better than any other metal except silver. And the major modern sources of copper have been the two Americas, North and South America, and Central and Southern Africa. So copper, even though it's a metal of antiquity, it is a key element of civilization. So here we are looking at the uses of copper and copper alloy products in the United States by purpose. And you see that by far the largest use is in building construction. And then electrical and electronic products, transportation equipment, consumer and general products, and industrial machinery and equipment. It is critical to just about everything modern civilization does. So let's just give you a sense of how much copper is in an average single-family home. It contains about 450 pounds of copper. There's 195 pounds of electrical wire, 150 pounds of plumbing tubes, fillings, and valves, 24 pounds of various brass goods, 47 pounds in the built-in appliances, 12 pounds in builder's hardware, and 10 pounds in other wires and tubes. So we really don't have a modern home without a lot of copper. Most copper is combined with other metals to form more than 1,000 different alloys, which include the brasses. The brasses are copper and zinc. The bronzes are copper and tin, and the nickel silvers, which is copper, zinc, and nickel combined. Copper was the second most utilized metal after iron until the 1960s, when cheaper and more plentiful aluminum surpassed it in world production. And the price of copper today is about $10,000 a ton. All right. Chile is by far the leading copper mining country in the world. So these are the big producers, and you see Chile is, way up there. In 2020, it made almost 6 million metric tons of copper, which is almost 30% of global copper production. Right behind it is Peru, and then China, the Democratic Republic of the Congo, the USA still produces significant, Australia, Russia, Zambia, Mexico, and Kazakhstan. So Chile's copper production has been rising. This is production in millions of tons per year, less than one in 1900. You know, here we are 2020, 2022 is over here. It's probably 20 million tons a year now. You can see how fast it's been rising. You know, basically doubling from the mid-1980s until today. So, copper has played a large role in Chilean economy since at least 1825, when British and Americans were already competing with other foreign investors to control Chile's copper. By 1835, Chile was exporting, 13,000 tons of copper, much of it to the United States, and it accounted for 55% of the country's economy by 1860. And Chile became very highly dependent on its copper exports. And then after the War of the Pacific ended and Chile captured the regions where a lot of the copper deposits were, the mining continued to increase. And the demand for copper put Chile at an economic advantage over other nations in the region, but it was very dependent on the copper price, so that put it at the mercy of the world market. When copper prices dropped or industrial slumps hit Europe, Chile's economy went into a tailspin. So, how do copper deposits form? It's basically back to the subduction zone. Remember, we've got the Pacific or the Nazca Plate being subducted beneath the western South America. We talked about these metal belts. You know, when we were talking about Potosi, we were talking about mineralization in the tin belt. This is the copper belt, which is west of the volcanoes, in the Atacama Desert. All right, these are porphyry copper deposits, and those are some, the porphyry is a funny word, so porphyry, geologists use porphyritic to explain with big crystals in a fine-grained matrix. So this is typical of shallow intrusions. So crystals of anything take time to grow, so this magma underground will, if it's allowed to cool slowly, but will generate lots of big crystals like this. But as the magma starts to move towards the surface, it begins to cool, and the remaining material is fine-grained, and so you end up with two different textures in the rock: coarse-grained large minerals and fine-grained matrix. That's a classic porphyritic texture. And it tells you you're dealing with a relatively shallow plutonic environment. So, mineralization of porphyritic intrusive rocks is the world's most important source of copper, and also molybdenum. We're not going to talk about molybdenum in this class, but it's an important element. It's also a significant core source of gold. And these porphyry ore deposits form within and nearby porphyritic intrusions, igneous intrusions, that are shallow parts of a larger igneous intrusion. And porphyry copper deposits form as a result of magmatic water that's dissolved in the magma, bubbling out of the magma while it's cooled, within several hundred kilometers of the crust. So you can think of shaken up soda, but this brings dissolved copper and sulfur up with it, and then the ore minerals will precipitate from this fluid as it cools and interacts with the solidified rock. All right, here's a cross-section of a porphyry copper deposit. And here we've got an intrusion. It's coming up. This is the shallow part. This is probably a volcano. Things will come out of here. And then you'll have all kinds of mineralization around it. But you won't even know it's there until you get erosion. So in order to expose the ore deposit, you've got to get rid of all of this stuff and erode down to this level, and then the deposits can be exploited. So many volcanoes may have these systems underneath them, but we can't exploit them. We have to wait for erosion to remove all of the rest of the volcano so we can see if it's there. All right, so as you recall from our discussions previously, there's ores that are two main kinds. There's oxidized ores. These are sometimes called gossans, and there are sulfide ores. And sulfide ores are what forms underground, and oxide ores are what forms when groundwater and air interacts with the sulfide ores. So there's always a sort of a cap of a gossan or an oxidized ore on top of a sulfide ore. And as you recall, we can it's relatively straightforward to extract the metal from oxide ores because you can use a huayra, heat it with carbon in a furnace, and extract the metal, whereas the sulfide ores requires a more complex treatment. We talked about the patio process for silver. That doesn't work for copper, but there are other methods for extracting the copper sulfide that are available today. So the sulfide ores are what's more important today. You know, the oxide ores are gone, and the sulfide ores are what are being mined. And the most important mineral for copper ores is chalcopyrite. It's a beautiful brassy crystal, which is a combination of copper, iron, and sulfur. And ores can be mined either by open pit or underground mining. Ores containing as little as 0.15% copper can be mined profitably in open pit. But underground mining is profitable only if an ore contains much more copper. And you may remember a disaster a few years back when quite a few Chilean miners were trapped in a mine. That tells you some of the reasons people don't want to do underground mining and would much rather do open pit mining. So let's go back to the metallogenic belts above the subduction zone. And here we see these belts. Today there are 14 open pit copper mines in Chile, and we're going to look at two of them, La Escondida and Chuquicamata. So here we have a satellite image looking down at the La Escondida mine. It's at an elevation of almost 10,000 feet. Started operating in 1990. Its current capacity is about 1.4 million tons of copper a year, making it the largest copper mine in the world, and also produces a lot of gold and silver. So what they do with the ore is they do the primary processing, and there's the pits, and then these are some of the things that came out of it. And the concentrate is then sent to the coast for further processing through a 170 kilometer long, 9-inch diameter pipe. So here we're zooming in a little bit more. This is a 10 kilometer scale. There's the mine, and you can see all of the things that are coming out of it. These are some ponds that are used for separating the copper. This is a view from a panorama. You can see these steps basically let the trucks go down. Can we see a truck? Maybe these are some of these trucks down here in order to get down. All right, the other one we want to look at is Chuquicamata, which is just 150 kilometers north of Escondida. And it is, the pit is 4.5 kilometers long and 2.5 kilometers across. And that is the size of the trucks that are used to haul the ore. So, Chuquicamata is the world's largest open pit copper mine. As we said, it's several kilometers long and wide and almost a kilometer deep. Shortly before nationalization, which we'll talk about, in the early 1970s, an American mining engineer journal called Chuqui, A Mine That Staggers the Imagination, the granddaddy of them all, by itself earning 1/3 of Chile's desperately needed foreign exchange income each year. So this is a little bit more detail. Now we're looking at 6-kilometer scale. And you can see this is the what they call the Chuqui Porphyry Complex. It's a big dike that trends for, what is that, maybe 30 kilometers and maybe a kilometer wide. And right now, this is the part of it that's being mined. But there's plenty more resources around that. So, Chuquicamata, the mining first began with burros and Bolivian highland Indians who lived in caves that they dug out of the surrounding mountains. It was not until an American millionaire, Guggenheim, brought in steam shovels, and these steam shovels had been bought from when they finished the Panama Canal, and they used these steam shovels to dig these big pits, this big pit of Chuquicamata. This is basically what launched it into its spectacular career as a moneymaker. And today the task of removing the ore and rock from the mine is done with these huge machines, 200-ton trucks and shovels that can take out 13 cubic yards in one bite. Now let's watch a 1.7-minute video that talks about how this kind of mining has affected the lives of people in the area.
Este es José. Él y María vinieron a Antofagasta, una de las 3 principales regiones mineras de Chile, junto a sus 2 hijos. La industria minera del cobre es importante aquí y crea empleo. Solo en 2016 generó casi 400.000 trabajos por sí sola. En las regiones mineras, la industria representa un 63% del PIB regional. Y los salarios en la minería son entre un 80% y un 110% más altos que el promedio regional. Pero María y José no necesitan ser mineros para beneficiarse de la industria del cobre. Por cada trabajo generado por la minería, 3,7 empleos adicionales son creados en otros sectores de la economía. Durante la mayor expansión de la industria minera entre 1990 y 2016, el índice de pobreza en Chile disminuyó más de un 30%. En las regiones mineras, la pobreza es hasta un 50% más baja que el promedio nacional. El medio ambiente es muy importante para la industria minera del cobre. Las empresas mineras son más innovadoras, siempre trabajando para ser amigables con el medio ambiente. Por ejemplo, la industria ha desarrollado formas de utilizar agua de mar en vez de agua dulce. Las empresas mineras se han vuelto más modernas y seguras para los trabajadores. Entonces, ¿qué significa la minería del cobre para Chile? Menos pobreza, salarios más altos, mayor innovación y, en general, una mejor calidad de vida.
I hope you enjoyed that video. Let's talk a little bit about Guggenheim. Some of you may know the Guggenheim Museum in New York, the very unusual design of Frank Lloyd Wright. And this is Solomon Robert Guggenheim. He died in 1949. He was an American businessman, and then to get rid of his money, he became an art collector, and that's why he left the money for the Guggenheim Museum in New York, and then had money left over to establish the Guggenheim Foundation. So, looking down at Chuquicamata, you can see this makes kind of a long, skinny kind of a pit. These benches are 100 feet wide that allow things to move up and down it. And so far they've removed more than 1 billion tons of rock from this. So the Guggenheims obviously did very well, and they decided to sell 51% of the mine in 1923 for $77 million to another company, Anaconda, which was the biggest cash deal in Wall Street history up to that time. Now, copper is produced well. This is the price per pound So back in the early 1960s, it was a few cents per pound, whereas now it's, somewhere between $4.50. I'm not sure exactly what it is today, but it's been going up. There are some spikes, but overall the trend is clearly increasing with time. So, Anaconda and Chuquicamata, Anaconda paid a lot of money for their interest, but it became a cash cow for Anaconda. So, Anaconda made a net investment of only $93 million in the 35 years in its two Chile operations. One was the Chuqui mine, and another one was this mine, smaller one we won't talk about. Over that time, Chuquicamata alone generated over $800 million in profits. So that's a pretty good investment. And in 1967, as the Vietnam War pushed world demand and prices for copper higher, Anaconda's Chile operations accounted for $4.05 of the company's total earnings per share of $4.31. So yes, that was quite an investment they made. All right, now the story gets interesting because the Chileans naturally are going, wait a minute, we've heard this story before. You come in, take our stuff, get rich, and we're left with nothing. Let's do it a little differently. And so they began the process of saying, why should an U.S. company get all this money when it's our country? So there was a movement to nationalize big copper. And we'll talk in future talks about nationalization of oil, but the idea that this copper is ours, we should benefit from it, is something that many people in many countries feel like, that the West is just coming in and colonializing, exploiting them again, and we want to stop that. So this nationalization was a national movement that gathered strength throughout the 50s and 60s, and it involved all of the Chileans, from conservative business leaders, to Marxists and the moderates as well. And Chilenization was called for the Chile government to own 51% of the copper mines. So Chilenization increased Chilean state financial participation in the copper industry and induced the foreign companies to make major new investments. And the fact that the high copper prices were just leading to astronomical profits for Anaconda and other companies fueled the desire to capture some of that for the Chilean people. By 1970, the Chilean treasury was receiving 84% of the big copper profits in the form of taxes and stock dividends. And by 1969, President Frey announced a pacted nationalization of Anaconda's properties, providing for 51% government ownership immediately and the right to purchase the remaining stock after 1972. So in 1970, there were elections, and it was a three-way contest. It was very close. There was the National Party, candidate Jorge Alessandri. There was the left, which was the Unidad Popular, which was Salvador Allende, and the moderate Christian Democrat Party, Radomiro Tomic. And Allende won by a small plurality and Allende became the first democratically elected socialist ruler in world history. So, nationalization of Chilean copper mining was already going on, and it was continuing. So nationalization of big copper was completed in the months following Allende's inauguration. By 1971, all parties in the Chilean Congress supported a constitutional amendment retroactively deducting all excess profits above 10% of book value since 1955 from the compensation to be paid Anaconda and another copper company, Kennecott. Acting on a Comptroller General's financial assessment, Allende 2 months later decreed $774 million in penalties against the two copper companies for excess profits and alleged defects. And because these penalties were greater than the book value of the mines, the government claimed that it owed the companies no indemnification. So we're taking over the mines and you're not getting a penny. And the companies might be miffed, but the Chilean nation as a whole thought that this was a good thing, that finally we are taking control of our own resources. Now the U.S. had a different opinion about this. So there was already a concern about Allende as a socialist leader, and the United States had already been planning to destabilize the Chilean economy. And Henry Kissinger, who was Secretary of State at that time, in a famous quote said, "I don't see why we need to stand by and watch a country go communist due to the irresponsibility of its own people." And as a result, the U.S. cut off loans to Chile, blocked the World Bank and other sources of money. We would recognize that as sanctions today. And the U.S. ambassador to Chile remarked, "Not a nut or a bolt will reach Chile. We will do all in our power to condemn Chileans to utmost poverty." So the Chilean economy worsened as a result in the drop in aid and the economic sanctions. Chilean industry couldn't buy spare parts, technology, new machinery, and inflation returned at the same time as a shortage of goods. Agriculture declined at the same time because land reforms were going on, and these disrupted production, and some landowners took land out of production. And Allende did not have a majority in Congress. He did not control the judiciary, did not have the loyalty of the civil service, and most importantly, the Army High Command. So, despite the inflation and increasing polarization of Chilean society, the Unidad Popular party, Allende's party, increased its share of the vote in the March 1973 congressional elections from 36 to 44%. In May, the copper miners went on strike. On June 19th, there was an attempted military coup. On July 29th, the truck drivers went on strike, and by that summer, Chile had split into two hostile camps. All right, so this is the other September 11th. In September 11th, 1973, a military coup led by General Pinochet overthrew the government. Allende died in the presidential palace. This is the last photo of Allende alive. His final words were broadcast to the nation, and I'll read them to you. "Probably Radio Magallanes will be silenced and the calm metal of my voice will not reach you. It does not matter. I have faith in Chile and in her destiny. Others will surmount this gray, bitter moment in which treason seeks to impose itself. You must go on knowing that sooner rather than later, the grand avenues will open along which free people will pass to build a better society." So, next. So this was Pinochet. He led the country for 16 years until 1989, and this military government took control of the country. First years of the regime were marked by serious human rights violations. We're not going to go into those in this class. A new constitution was approved by plebiscite in 1980, and General Pinochet became president of the republic for an 8-year term, was elected. And slowly, with time, the regime gradually permitted more freedom of assembly, speech, association, and trade union activities. The military government let the companies pretty much do what they want, although They never reversed the nationalization of the copper mines, but they did allow foreign companies to come back in and invest in new deposits. So in another election in 1988, General Pinochet was denied a second 8-year term as president, and they voted to choose a new president and members of a 2-chamber Congress. So, in an interview in February 2003, U.S. Secretary of State Colin Powell said that encouraging the coup that brought General Pinochet to power was, quote, not part of American history that we are proud of, unquote. But today, Chile has a functioning democracy, and this new president was just elected, I think, in March. And so that's kind of the story of nitrates and copper in Chile. These resources are very important and can cause a lot of strain in the society as well. But if you want to learn more about copper and how important it is for the new energy sources we're hoping will replace fossil fuels, watch this 9-minute video.
This is a chart showing the price of copper, or, well, the price of copper futures contracts at the New York Mercantile Exchange over the past 2 decades. Let's zoom in on 2021. All year, copper prices have been surging, just a straight shot higher.
Copper up more than 30% this year.
Well, demand for copper has dramatically increased.
But I'm talking about the fundamental story for copper is a long-term, very positive one.
Let's zoom back out. See that big dip at 2008 going into 2009?
The last time copper prices got high, just before the financial crisis in 2008, 2009, people were stealing copper wires out of homes that were being constructed. They were going into other buildings and ripping out plumbing pipes and copper wire.
Copper has played a big role in the world economy for thousands of years. The Bronze Age? That happened because blacksmiths figured out how to forge copper with tin. Now copper is used in electrical and heating equipment because its chemical properties make it such a useful conductor. It's used in car motors, household pipes, washing machines, all sorts of things we use every day. That's not to mention all the different copper alloys that get mixed into other metals and items. Also, the metal is so easily recyclable that most of the copper on Earth remains in the ground. In fact, only about 12% of all copper on Earth has been mined throughout human history, and nearly all of it remains in circulation. Some copper in circulation right now could have once been jewelry or armor in ancient Egypt. So why are smart people like commodity analysts at Goldman Sachs warning about a copper shortage, with dire consequences for the world economy? In May 2021, investment bank Goldman Sachs released a note calling copper the new oil. More importantly, the bank said copper prices could double in the next few years, jumping from just over $9,000 per ton to $20,000 per ton by 2025.
Copper is the single best conductor of electricity known to physics as well as the periodic table. So if we're going to electrify the world and decarbonize that way, we absolutely need copper to do it.
I agree with that. The tenor of those reports was that higher prices would have to incentivize new supply. And the tenor was that if that doesn't happen, we would have a copper shortage in the future. But it's not that we have a copper shortage currently.
Wall Street basically thinks copper could play a huge role in 2 major trends: electric vehicles and decarbonization. At the same time, there's not enough copper getting mined from underground deposits or coming from scrapyards to feed the coming demand.
The industry cannot continue to do what it has previously, or else there really is going to be a severe copper shortage. As soon as all these big car companies start making more electric vehicles, it will happen like a light switch. We'll see that there's a copper shortage.
So the so-called shortage isn't the world running out of copper, it's more about the current mining and recycling infrastructure not being able to meet a potential boom in demand.
I would, on a longer term cyclical view, think that this is actually a great opportunity to position oneself for a long-term copper bull market. Why? Because of these demand drivers going forward. And the biggest demand driver going forward over the next decade is green tech.
When you have further electrification, you need more wiring, you need more electrical components that conduct electricity and make these things run. Copper is critical to that. And so people are just starting to realize just the magnitude of copper's presence throughout the economy.
For a while now, commodities traders and economists have had a special nickname for copper.
Well, they call him Dr. Copper for a reason.
Well, Dr. Copper is saying that we are going to go and test those lows.
We tend to call it Dr. Copper because people tease it has a PhD in economics.
So when economic activity increases, the demand for copper increases, and then copper prices increase. In that sense, the copper market becomes a barometer for global economic growth, a leading indicator. Dr. Copper doesn't always provide a surefire diagnosis. Sometimes the connection between copper prices and economic growth breaks down. Copper is important for a lot of different local economies as well. Where does copper come from?
In the last 50 years or so, South America has become very important. Peru and Chile really dominating the copper supply there. Arizona is the leading copper producer in the United States, and if Arizona was a country, it would probably be 5th or 6th on the list in terms of top producers. Zambia in Africa has a very significant copper belt. There's a huge mine in Mongolia. So I would say, basically, if you think about the Pacific Rim, as you come down the western United States and through the Andes, that region has a lot of copper. And then if you go over to the Asia side of the Pacific Basin, then you're going to pick it up through Papua New Guinea, up into Mongolia and Indonesia. So kind of the whole Pacific Basin, and then some in Southern Africa.
The copper industry is bracing for a boom in demand. Governments and companies around the world are preparing for a green energy revolution. Entirely new power grids using solar, wind, and water to power turbines and feed electricity into copper wires. What's more, electric cars need much, much more copper than their gas-powered counterparts.
A typical gas-powered car have about 50 pounds of copper, but an electric vehicle is more like 184 pounds of copper. 3.5 times more copper because you have more motors in the batteries in an electric vehicle, more electronics. Solar, similarly. Conventional energy, normally you think about 1 metric ton of copper per megawatt of generating capacity. Renewable energies are 4 to 6 times that amount of copper. Solar installation could be something like 9,000 pounds per megawatt. Wind farms could be as much as 15 million pounds of copper. An individual wind turbine's about 800 pounds. So as we move to a decarbonized economy, we're replacing C in the periodic table with Cu.
Higher copper prices may have a silver lining. They'll cause mining companies to break ground on more new projects, since extracting copper will have a bigger payoff. There's also new technologies springing up to extract copper, like Outwin's company, Jetty.
Jetty unlocks fast-stranded copper resources. We do that using a catalytic technology that was developed in partnership with the University of British Columbia with the intention of breaking the sulfur metal bond that exists in copper ores. For many decades, there's been an issue that the copper mining industry has been trying to solve for, which is oftentimes called the Holy Grail. And that's being able to use hydrometallurgy, the use of solutions, getting them in contact with copper ore, and being able to extract copper from low-grade material. Because there's a huge amount of copper that's stuck in low-grade material at copper mines, which historically was thought of as waste. Jetty specifically operates in the hydrometallurgy realm. We produce copper cathode. That comes from leaching at big copper operations. Leaching uses 2 to 3 times less water than traditional extraction methods, has a much lower emissions profile, and the industry has an interest in producing more copper in that manner, greener copper.
The boom in copper demand is just the beginning. Mining companies will have to strike a delicate balance. Rising copper prices means there's more demand for mining projects. If prices get too high, like astronomically high, Companies could look for alternative metals for their green energy projects. At the same time, more copper mining means more of the metal enters the economy, which could bring prices lower, leading to fewer mining projects and back down to the current situation: tight supply, high demand.
All right, thank you. And our next lecture will be geothermal energy in Latin America.